So in the last lesson, we were discussing about the Azure Firewall, and we've seen how we can configure the Azure Firewall and DNAT rules, and how we can enable the incoming traffic from internet to the virtual machines, and how we can secure the virtual network. So in this lesson, we'll understand Azure route tables. Okay. And maybe there could be a lot of very deep concepts inside the route table, but the Azure route table is a simple concept, but we'll try to understand as easy as possible. So before we go into the Azure route table, let me take a simple example. Now we have a location called as in Hyderabad. And we have location called as Bangalore. Bangalore. So now we need to travel from Hyderabad to Bangalore. So generally people will ask us from who. So from where you want to travel to where you want to travel. So in a computer terminology, we call it as a source. In computer terminology, we call it as a destination. So in a general terminology, we call it, hey, I'm traveling from Hyderabad to Bangalore. That's how we basically speak to people. We say that, okay, I'm traveling from Hyderabad to Bangalore. But when we see from a computer networking terminology, we call that as a source and a destination. So from where to where you want to communicate. Now, in order to, a person who is sitting in Hyderabad want to travel to Bangalore. So now he need to know the route. So basically we call it as a path. Someone who want to travel to the Bangalore should know the path to reach Bangalore. So if he doesn't know the path, he will not be able to travel to the Bangalore. Now, if someone from an Hyderabad would like to travel to Bangalore over the car, the first thing he will look at is a path. So how do I basically, which path I need to take to reach Bangalore? Now we need to know the path. So when we see a path, so from Hyderabad to Bangalore, first we would see that, okay, first I need to reach Karnool. Now from Karnool, I have a challenge. Now from Karnool, there are routes going to Kadapa. There are routes going to or there are 4 different places where Karnool is going to connect. One we see called as in Kadapa, one is in Ballari, one is in Anantapur. So now when we reach Karnool, the question mark comes here now. There are 4 roads in the Karnool. Now which road has to be taken? Now which path need to be taken? Now, so as you see that from, in order to reach Bangalore, so first I need to reach Karnool. So when I need to reach Karnool, So as soon as I reach a kernel, then I see four different circle with the four different paths. The path which I traveled, then I see three different paths. There is one path to the left, one path to the right, one path to the straight now. Now there is a question mark which says that which route I need to take to reach Bangalore. Now as part of that, I see that in order to reach Bangalore, I need to reach Anantapur. I need to reach Anantapur. Now first I reach Anantapur. Now here I see in the board which talks about, hey, there is, in order to reach Anantapur, you need to go straight, or you need to reach, go to the Bangalore, you need to go straight. So normally we see on the junctions, the boards, which is reflecting the path, which path you need to take for which destination. So now in the kernel, basically the signals. So we see a path saying that, hey, in order to reach Kadapa, go left side. In order to go to the Ballari, take right. In order to go to the Anantapur or Bangalore, you see you need to go to the straight. Now, the signals and the path indicators in this particular signal will tell you that which path you need to take it. Now, from Kurnool, I took the straight path, then I reach Anantapur. Now, there is a junction in Anantapur now which has a four different paths, destinations. One is saying Chennai, one is saying Bangalore, one is saying called as Ballari. Now, the question here is now, which path I need to choose to reach Bangalore? Now, again, the four different paths which has come here. When I reach the signal in Anantapur, I see there are four different paths available now. Now, question mark comes over here now. Which path I need to take? Do I need to go left or straight or right? Now, the path indicators will tell you that, okay, in order to go to Chennai, you need to go to the left. In order to reach the Bangalore, you have to go to straight. You need to go to the right in order to reach Bangalore, Ballari. Now, so in order to reach Bangalore, so from Anantapur, so I need to know the path so now the path indicators in the signal of Anantapur will tell you that, hey, take left for Chennai, go straight for Bangalore, take right for Ballari. Now, what happens if you don't have this path indicators? If you don't have path indicators, now there is a confusion that which path I need to take, then I will not be able to move forward because I really don't know which path I need to take to go to the Bangalore. So now, when I want to travel from Hyderabad to Bangalore, there are so many junctions which comes, and each and every junction, I need to basically see the path, and I need to say that take the path, and I need to take the another path. Now, in each and every path, we need to, which in each and every junction, we need to identify the right path. So what happens in a computer terminology now? Now, from Hyderabad to Bangalore, you need to reach it. But when we see from a Hyderabad, sorry, when we see from a computer terminology, let me put this particular diagram in a different way. This is my Azure VNet, which is 172.16.0.0/16, or I'll take a 24. This is one network which is in Azure. Now I have on-prem network. This is an on-prem network, which is in 192.168.10.0/24/24. Now there is a requirement that the resources which are sitting in Azure Virtual Network should communicate with the on-prem servers. And similarly, the on-prem servers should communicate with Azure Virtual Network servers. So maybe the VMs which are sitting in Azure, the applications which are sitting in the Azure Virtual Machine should communicate with the applications which are sitting in on-prem. And similarly, the applications which are there in on-prem should communicate with this one. Now, what happens in this case now? So how do they basically now? As part of this one, so when we go to the, let's say this is a virtual network, or I would say a network. A virtual network, or with multiple subnets or whatever it might be. So I'll take a subnet 1, subnet 2, subnet 3. And virtual network is 172.16.0.0/16. So I'm selecting subnet 1, 172.16.0.0/24. Subnet 2, 172.16.1.0/24. Subnet 3-172.16.2.0/24. Now the resources which are sitting in this virtual machine, the virtual machine which is sitting are connected to this particular virtual network. Now within this virtual network, by default, internally, there is one device called as a router, which is not basically visible to us, and which we don't have a control on this. So when we deploy a virtual network, so internally, the Azure is going to create one router, and all these subnets are connected to this router. All these subnets are connected to this particular router. So now what happens in this case is then, so by default, the router will route the traffic from subnet 1 to subnet 2, subnet 3, and all the subnets, the router is going to route the traffic between all these subnets. Now we have, so when we have a VM assigned a public IP address, the traffic from the virtual machine will route through the router over to the internet. Now all the outbound traffic which is going to the internet, this is to internet, is going through the internal router. Now, so we don't have a control on this router. Now what we did, so we have configured a firewall. Now we have a firewall. So we deployed a firewall. Which is Azure Firewall Subnet 255.0 subnet. Now where the firewall is connected to this particular one. Now the firewall is also connected to the internet. So as I said, by default, all the subnets are connected to an internal router. So when these machines reach the internet, they go to the router, that is an internal router, and from there they go to the internet. But even though we deployed a firewall, the resources which are sitting inside the subnets, inside the virtual network, in order to reach internet, they don't go through the firewall. Now the question mark here is on, now when the virtual machine which is sitting in this subnet, in order to reach internet, does it need to go through internal router or it will go through the firewall? If it goes through the router, then the firewall will not control the traffic, because the outbound traffic from the resources virtual network is not going through the firewall, because the router is routing the traffic to internet directly, which we don't have a control. Now we cannot control the inbound or outbound traffic, because the outbound traffic from the virtual machines is directly reaching to the internet. Now what is our requirement now? Now in order to secure our network, we don't want internet to be available on subnet 3 machines. We don't want internet on subnet 2. We want to allow only on a specific machines in subnet 1 to reach internet. I want to control certain URLs. I want to allow only specific URLs. Now, if I want to control all these access, these machines should reach firewall in order to reach internet. Then we can have basically firewall policies which can allow or deny the restrictions, which can control the outbound traffic. Now, so if the virtual machines are not going through the firewall, then even though if we define the policies, it cannot be controlled, because the traffic is going through the internal router. Now we have one more. Now we have something called as a VPN device. VPN device. Now this VPN device is connected to one of the subnet called as a gateway subnet, which is let's say 254.0. And there is a device called as a VPN device. Now this VPN device is connecting to an on-prem network. Connecting to an on-prem network. Now which is an 192.168.1.0/24 network. Now there is a VPN device on the on-prem network. Now these two are connected each other. Now when we with virtual network, the resources sits inside this virtual network. In order to reach on-prem network, they have to go to the VPN device. In order to reach internet, they have to go to the firewall. In order to communicate between the subnets within the virtual network, they need to reach the router. Now, how does the device which is sitting in this one will know that if I want to reach the internet, it has to go through this one? How does it know that in order to reach internet, it has to go this one? Now, on a device, let's say on a server or a device, we see IP, subnet mask, then we see default gateway. Now we give IP address as an 192.168.1.10, and we are giving subnet mask as 255.255.0, and we're giving gateway IP as 192.168.1.1. Now, what is this IP address we are giving as a default gateway? Now, the default gateway this is the next device to reach unknown network. This is the next device to reach unknown network. What does that mean? That if there is any other machines, if this machine is communicating to 192.168.1.15, now this machine IP address is 1.10. It is trying to communicate with 1.15, which is in the same network. So they will directly establish a communication. Now, if this device want to communicate with 15.15, now the destination device is not in the same network. So when the destination device is not in the same network, the system will try to reach the default gateway device, whatever the IP address which has been given here. Now this device, the default gateway device, will route the traffic or will take or forward the packet to the next connectivity device, connecting a device. Now what happens in this case? When we give a default gateway, on every device, there is a default route is being configured for any destination, which is 0.0.0/0.0.0. The default device is 190.160.1.1. So when I go to this particular device, when I say an IP route details, I see one route default route called as an for any devices apart from the local network, it has to reach this device. Now with that, what happens is when we go to this network, by default, subnet 1, subnet these devices, they'll be pointing to the router IP address as a default. That is the reason why what happens here is now from this device, if I try to reach internet, as internet is not, a device is not available in the same network, it goes to the router will forward the traffic to internet. If you want to reach the on-prem network 1.10, as the default gateway device is a router, this machine will forward the packet to the router, but the router is connected to the internet, but not to the on-prem network. Now what happens in this case now? This device will reach the router, but the router will not forward the packet because it is not a public IP. It is a private IP which is connected to the on-prem network, but this router doesn't know or does not know how to forward it. Now, what is required for us here now? We need to tell these devices that, hey, in order to reach on-prem network, which is 192.168.1.0, the traffic should go to the VPN device. The VPN device IP address is 19.168.254.4. The device IP address is 198.168.254.4. In order to reach internet, the traffic should go to the 198.168.255.4, which is a firewall. Apart from these things, any other things, the traffic should go to the router. Now, my statement is, now these devices should know that in order to reach on-prem network, they should contact the VPN device. In order to reach internet, they should contact the firewall. Apart from this internet and these things within the virtual network, it should contact the router. Now, as a path here now, this is virtual network, on-prem network. This is your VPN device. There could be internet provider. Now, each and every device, this is what we call them as an hubs. Basically, on hubs, what we call them as an or gateways, which is going to route the traffic between various networks. Now, in virtual networks also, we need to define the path. We need to tell the path, which path it need to take. That is what we called as a gateway. Now, the Azure route table so allows to define the custom routes on the virtual network. So wherein which can controls the forward of the traffic to various destinations. The route table consists of routes, which is nothing but the paths to reach the destination. So which is the next device to be contacted or to be reached. So in order to reach on-prem network, which is 192.168.1.0 network, so these devices should reach the VPN device, which is 254.4. In order to reach internet, these devices should reach the firewall IP called as a 255.4. Now the routing table consists of the paths to reach the destination. So which is the next or the next device to be contacted or to be reached or to be forwarded. Now the routing table can be applied at the individual subnet level. So we need to define this at the subnet level. So individual subnet can have individual routing table. All the subnets can point to the same routing table. So once we apply a routing table or map a routing table to a subnet, then the routes will get updated to the devices. Then basically the router will see that, okay, hey, in order to reach the traffic to the VPN, I need to forward to this device. In order to reach the traffic to the internet, I need to forward the traffic to the firewall. Now what happens here now? The internal router now will know that, okay, if you want to route the traffic to the VPN device, I need to forward the traffic to the VPN, which is 254.4. If the packet has to go to the internet, then I need to forward the packet to the firewall device, which is 254.4. Now with that, what happens is the router basically, which is internal router, will control the forwarding of the packets to the either to the firewall or to the VPN or to any other device where it has to go. Now, when we apply the firewall policies, as all these devices will go to the internet over the firewall, then we can control the traffic over the firewall. Then automatically the apply or deny rules or the allow or deny rules which we have applied will be applied. Accordingly, the traffic will be controlled. So now, so these are nothing but the routers. The gateways, whatever the vehicles called as the routers will define in order to reach the next device, it has to go this path, in order to go this one, this path, this path. Now here, the router is taking a path. So it has three different paths. One path to go to the firewall to reach internet. One path is to reach VPN, to reach the on-prem network. One path is to the basically the internal subnets. Now, if the device is communicating with the internal device, the router will route the traffic like this. If the internal device is communicating with the VPN, it goes like this. If the internal device is coming to the internet, then it will come to the router and firewall to the internet. So now the routing table will help us to define the custom routes basically or control the traffic forward to internet or to the on-prem networks to or any other networks. Now, when we do a peering between the two virtual networks, now we have seen a peering concept which is there. So where we can establish a communication between the two virtual networks. So when we establish a peering, the routing information is being automatically updated within the internal routers. And that is where the internal routers will forward the traffic from one virtual network to the another virtual network. So in a case of peering, we don't need to manually update the routing table or route path. Because automatically when we establish a peering, the internal route information is being updated to the internal router of it. Okay. Let's see that how we can implement the routing tables. Let me create a virtual network. So I'm creating two subnets. Review and create. So let me initiate two virtual machines. VM1. So I'm creating a subnet one. I'm giving a public IP. Review and create. create. So what I'm trying to do here now, so I created a virtual network. I created one virtual machine in subnet one. So which is going to be a private IP called as 172.16.0.4. The IP of this one will be 0.4. I'll create one more virtual machine in another subnet, which will be an IP address called as 1.4. VM2. I'm selecting subnet 2, review and create. Create. Right. So while VMs are getting created, let's go to the virtual network. I'm just doing a multitasking over here to just save the time. So I'm going to the, we just created a virtual machines. Then I'm at the virtual network. Then we would see an address space, subnets, firewall. Let me go to the firewall. Let me create a firewall. Before that, we need to create one subnet. Let's create a firewall subnet. Firewall subnet. I'm giving it 255.0. Now let me create a firewall. I'm saying acute firewall. Create a new policy. Acute firewall F1 policy. Then virtual, use the existing virtual network. VNet. We created right. Azure firewall subnet. Why this? Did I give any? Azure firewall subnet? Yeah. Acute firewall policy. Use virtual network. Yeah. I'm adding a public IP. I'm saying acute firewall public IP. Next. I'm just creating a firewall. So what we did here now, so we enabled a firewall, created a firewall and connected to this virtual network. Connected to this virtual network. So we created a gateway firewall subnet. So within this virtual network, then we enabled a firewall in the virtual network. Let's go to the virtual machines. So while the firewall is getting enabled, now let's see this virtual machines as a public IP. I'm able to access the virtual machine. I'm trying to access another virtual machine. Now, what happens in this case? So now these two virtual machines are reaching the internet via the router. So as of now, the virtual machines are trying to reach internet via the internal router. So I say IP config. So we see 107.16.0.1 is the default gateway. Then route print. We see the default route to any network. It is going to this 0.1. And as this has a public IP, I'm saying www. What is my IP address.com. So this will give you the which public IP you're using. Now we see that my VM IP 20.235.151.207. So now this VM has a public IP associated, this directly going to the internet. So even though we deployed a firewall, the traffic is not going through the firewall. So I take another machine. Now we can see 107.16.1.1 is the gateway. When I see a default route, it is going to the 1.1. Now the interface of this IP address on the router is a 0.1, 1.1. Now these machines are reaching traffic to the internal router and they are going outside. CSE 4.247.223.37. Now this is the virtual machine IP. Now what is happening here now? Both the machines are having a public IP addresses. They are directly going to the internet using their public IP addresses. Even though there is a firewall available, but the traffic is not going through the firewall. Now, so let's go to the firewall. So even the firewall is being created, Now let me go to the route tables. Oh, sorry, let me take the private IP of the firewall. 254.4 is the 255.4 is the private IP of the firewall. So I'm going to the routing table, create a route table. Route acute route table. I'm saying review and create. Create. So we create a routing table. Let's go to the routing table. You can click on routing tables and you'll be able to see a routing table here. So I'm just clicking on the acute route table. Now here we see routes. The subnets which are being connected as of now subnets, and there are no routes available. I'm adding a route to internet. I'm saying destination IP address to any destination. To any destination. So I'm saying that virtual appliance, which is hop is in the firewall. So I'm saying that in order to reach any IP addresses, the traffic should be forwarded to the virtual appliance, which is the firewall IP address. Now, can be a virtual network gateway, virtual network, internet. Now we'll talk about that later. I'm just taking this one, add it. So now what we define here is in this routing table is in order to reach internet, the traffic should be forwarded to your virtual appliance, which is a firewall, which is running an IP address called as 107.16.255.4. Now we just create a routing table, but we not applied this routing table to the subnets. So we see that there are no subnets. There are two ways which you can do it. One, you can go to the routing table, click on associate, and you can select the subnet to be applied. This is one way. The other way is you can go to the virtual networks, click on subnet. So I'm going to subnet 2. So in the subnet, you can see a routing table. You can select the routing table and you can save it. So from the routing table, you can map the routing table to the subnet, or by going to the subnet in the virtual network, you can basically attach the routing table. Now we can see here subnet 1, routing table, subnet 2, acute routing table. Now we see that the moment we applied a routing table, we lost the connectivity to the virtual machine. We lost the connectivity to the virtual machine. Now what happened here now? The moment we defined a routing table, and say that now any traffic which has to go to the internet, it has to go through the firewall. Now earlier, these two virtual machines were going directly to the internet and which are directly accessible using the public IP. Now we have applied a route saying that if any resources in this subnet should reach to the firewall in order to reach internet. Now this firewall is blocking the traffic. Now these virtual machines, public IP addresses, all the traffic is routed through firewall. Now they got blocked. That is the reason why we see we lost the connectivity to both the virtual machines now. Now what happened now? Even though there is a public IP assigned to the virtual machine, we are still not able to access it. See that I cannot reach that machine. Now what we will do now? We will go to the firewall. Now this connectivity is lost now. We'll go to the firewall. Now we will route the traffic from internet DNet to these virtual machines. So I'm going to the firewall. A policy, a DNet rule. First, I need to create a public IP. Let's go to the public IPs. Add a public IPs. There are no public IPs. Okay, let me take a VM1. As of now, there are no public IPs. Let me go to the virtual machine 1. Disassociate the public IP on the virtual machine. I'm removing the public IP on the virtual machine. So I'm going to the virtual machine 2. Network settings. I go to the IPs. Disassociate a public IP. Now we reboot the public IPs on both the virtual machines. So I'm going to the firewall. I'm adding the public IP addresses to the firewall. I'm adding VM2 public IP to this. Let me add one more VM2 public IP. Still updating is going on. Let's wait for. I'm just adding one more IP. Now we'll configure a DNAT rules that any traffic received on this public IP on a port number 3389, it should forward to this virtual machine. Any traffic received on this public IP on a port number 3389, that should be forwarded to this virtual machine. Let's go to the firewall policies. So I'm configuring a DNAT rules. DNAT 1, giving a 200. Name VM1. Source IP address from anywhere. Protocol TCP. Destination port 3389. Firewall public IP. Private IP of the virtual machine. 16.0.4.3389. I am putting one more rule, 3389. 172.16.1.4. Public IP of the VM2. Port number 3389. TCP protocol. Source from anywhere. IP address VM2. So we configured two DNAT rules. Now, so what we are telling now? So any traffic on these. So now we have assigned a public IPs to the firewall 3389. Now we specified that they should get forward to the 1.4, and the traffic on this public IP should get forwarded to the VM1 of it. Now on the firewall, so we configured that any traffic received from internet on 3389 on this public IP forward to this VM, on this one forward to this VM. Now let me go to this one and do this one. So still I'm not able to access the VMs. So why? It took some time. Let's see. Yes, now I'm able to log in. So I'm able to log into this VM. I'm able to log in to this another VM. Now the firewall rules got updated. Now we are able to access these two virtual machines from the public IP addresses, which are being mapped on the firewall with the DNAT. Now we updated a routing table that in order to reach the internet, this VM should go to the firewall. Now I'm going to this VM. I'm going to the edge. I see that I don't reach internet. Saying action deny, no rule match, proceeding with the default action. So I'm not able to access internet. I'm saying www.google.com. It says cannot be reached this page. I'm going to another VM. We are not able to reach internet. It's saying no rule match proceed. Now what is happening here now? So from internet, we are able to connect to the virtual machines, but from the virtual machines, we are not able to access internet. Now the traffic from the virtual machines is routing to the internal router. The router is forwarding to the firewall. The firewall is blocking the traffic. Now it's dropping the packets. Now we don't have any allow rule configured in the firewall to allow these virtual machines to the internet. We only created a DNAT. So we create only DNAT rule. Now what, in order to allow the internet, now we have network rules and application rules. So now what I'm trying to do, go to the firewall. First we'll see an application rule. I'm going to the application rule. Add application rule collection. I'm saying app rules collection. I'm giving a priority as in 300. Allow application rules. Name, I'm saying VM traffic. Source type IP address from any IP address to, I'm saying HTTP traffic, comma, HTTPS traffic. I'm giving FKDUN. I'm saying star.microsoft.com. I'm saying allow VM traffic from any IP address, which is HTTP and HTTPS traffic, to star.microsoft.com. So now what is that rule I'm telling here now? In the firewall application rule, that the application rule says that from internet to the outbound, from internal network to the outbound, which is to the internet. Now I'm saying that any traffic coming from this virtual machines or any resources in this virtual network to the internet, allow only star.microsoft.com. Rest all denied, because we allowed only star.microsoft.com. So now I'm going to the virtual machine. I'm saying sometimes it takes a minute to update the rules. Now I see that I'm getting Microsoft.com. I'm able to go to the Microsoft.com. But I can navigate to the entire Microsoft because we give a star.microsoft.com. I go to the oracle.com. I still see that I'm not able to access the Oracle. I'm saying a portal.azure.com. Still it is denied because we allowed only star.microsoft.com. Now I'm going to the an application rules. I'm adding a one more rule. Application rule. I'm saying an application rule. I'm saying Oracle. Source IP address from any source. FQDN. I'm saying star.azure.com. And HTTP, comma, HTTPS traffic. Now I'm allowing Oracle website from any source. Still it is getting updated. Let's wait for it. Let's give it a try. Now I see that portal dot. It is going to the microsoftonline.com. That is the reason why it is not doing that. Now I'm saying www.azure.com. Now as allowed, it is getting redirected to the azure.microsoft.com. But when I go to the oracle.com, still I'll not be able to access the Oracle. Let me go to another virtual machine. I type google.com. I type microsoft.com, sorry, oracle.com. I'm typing www.microsoft.com. So I'm able to access Microsoft.com website, but not Google and Yahoo because it has been restricted. So now what I'm going to do is from this machine 0.4, I'll allow oracle.com. I'm saying Oracle source IP address. I'm saying 170.16.0.4. From a specific IP address, I'm saying install.oracle.com. Oracle.com. I'm allowing HTTP traffic, HTTPS traffic. So I'm allowing from only one virtual machine, oracle.com. So whereas the Microsoft one, we allowed from anywhere, there is any virtual machine, Azure.com also from any virtual machine. But Oracle.com we allowed only from the specific virtual machine, which is 0.4. So I'm going to the 0.5 machine. I'm still going to navigate to the Oracle. I'll go to the 0.4 machine. I'll type www.oracle.com. Now we can see called as an Oracle, a cloud of it. Now from this machine, we are able to access the Oracle website, which is 0.4. But whereas the other virtual machine, we are not able to access it because the firewall is going to control the traffic based on the rules. Now we configured an application rules to allow the inbound and outbound traffic of it. So that is how you can use the routing table to route the traffic to the next hop device or gateway device to reach internet or to reach your destination and networks. So in the next class, we will try to understand the VPN features available on Azure Virtual Network.